Okay guys, so this is Unit 6. This will be Lesson 1, Energy and Temperature. The objectives for this lesson will be to distinguish between temperature and heat. They are not the same things. And you will also perform simple temperature conversions between Celsius and Kelvin. These are the units used in chemistry for temperature. And you will learn that you can find these conversion factors on your reference table. So your warm-ups will be done in class for this unit. Make sure you have a piece of paper ready for your in your binders every day. The warm-ups will be a review of the material from previous units as well as this unit. Like I said in class, I'm going to be going over midterm questions that I felt were pertinent and important to go over for the rest of the year. All right, so let's start with our notes. Energy and temperature definitions. Energy is the capacity to do work. So we're going to write that in there, capacity to do work, or the ability of matter to do work. The kinetic energy is energy of motion. Many of you may remember that from about 8th grade science. And that is associated with temperature change. Okay, potential energy, or also known as phase energy, is the energy of stationary or stored energy, so energy of position, we're going to say. And that will be stationary or stored energy. This is associated with phase change, therefore hence phase energy, not temperature change. So when we're talking about potential energy, we're going to talk about going from solid to liquid to gas, or solid to gas, and so on. So temperature is the measure of the average kinetic energy of a substance's particles. So a change in temperature, in this symbol, which is called delta, means change. So a change in temperature means a change in kinetic energy. It does not depend on sample size. So in other words, this is going to be a set amount, okay? It's going to be measured in degrees Celsius, degrees Fahrenheit, or Kelvin. We do not use degrees Fahrenheit in chemistry, but we can convert to Celsius and Kelvin and so on. So heat is the quantity of energy, or the amount of energy. All right, it's not temperature. And can only be measured as it's transferred from one hotter object to another cooler object. So we're going to put transferred here. And it's always going to go from high to low as far as transfer of energy. It does depend on sample size. The larger the sample, the more heat needed to bring it to the desired temperature. This is going to be measured in joules, kilojoules, or calories, which we don't really use in chemistry, so we're going to focus on joules and kilojoules. Remember, kilo means 1,000, so this is actually going to be equal to 1,000 joules, okay, kilojoules. Note, although there's a direct relationship between temperature and heat, they are not the same thing. One is a quantity of energy, and the other is the measure of average kinetic energy. Okay, so we're going to look at a diagram here, graphic organizer, where we have heat and temperature. We're going to separate the differences and the similarities. So heat is the measure of transfer of kinetic energy, and the temperature is the measure of average kinetic energy, and the kinetic energy is where they overlap. Okay, we're talking about kinetic energy for both, so that's how they're similar, but one is the measure of the transfer of the kinetic energy, the other is the measure of the average kinetic energy. So let's look at our temperature scales. We have 3, like I mentioned before, Fahrenheit, Celsius, and Kelvin. Okay, as chemists we use 2 of these scales, degrees Celsius and Kelvin. Absolute 0 is equal to 0 Kelvin, or 273 below 0, okay, degrees Celsius, and the temperature at which all particle motion ceases. I want you guys to check out this website, okay, this little link here, to give you a little more information on absolute 0. I may ask a question, might be your bonus points, don't know yet, we'll let you know, or I will let you know. Okay, thermometer scales are calibrated by two fixed positions. You need to know this. The first one is the freezing and melting point of water, which is 0 degrees or 273 degrees Kelvin, and the boiling point of water, which is 100 degrees Celsius or 373 degrees Kelvin. So notice the conversion factor is 273 Kelvin. We don't say degrees Kelvin, we just say Kelvin. There's a direct correlation between the Kelvin and Celsius scale, which is what makes it very easy to convert from one to the other. They are to the same scale, only shifted. So a change of 1 degree Celsius is the same as a change of 1 Kelvin. Or in equation form, change 1 degree Celsius is equal to a change in 1 Kelvin. They are proportionally the same. Direct relationship. So if we look at our temperature scales here, Fahrenheit, Celsius, Kelvin, notice 100 degrees Celsius is equal to 212 degrees Fahrenheit, which we use in our everyday scales now, and Kelvin, which is 373. So it's a difference of 273. Room temperature usually is about 27 degrees Celsius, so we're going to just put that in there. You don't have to know that, but it's roughly around there. And then we are looking at the freezing and the boiling. Okay, so those are our two fixed points on the scale. They will never change, and they are directly correlated with each other. Water freezes at 32 degrees Fahrenheit. That's what you guys are used to. Okay, freezing, 32 degrees. But it's actually 0 degrees Celsius. And then here's absolute zero, way, way down here. This is when all particle motion stops. And we will never actually be able to reach that. Otherwise, if we did, we wouldn't be here. Okay? So let's look at our temperature conversions. We're going to use the formula in Table T. Like I said in the beginning, this is given to you. You don't have to memorize it. It's on Table T. So what Kelvin temperature is. Okay, so when we try to figure out Kelvin temperature from our degrees Celsius, we have 35 degrees, and then we simply use this equation here and add 273, and we get 308. For number 2, it says the classroom has a temperature of 21 degrees. What is the temperature of the classroom in Kelvin? So we take our degrees Celsius, we add 273, and we will get, simple, let's use our calculators that we are so reliant on, 294 Kelvin. Okay, remember, do not put that little degree symbol there. So what I want you to do for practice is try to do 3, 4, and 5 on your own, okay, using the formula indicated. Okay, and then come back to the video and check your answers. Okay, so now that you did your problems, check your answers. 3, you should have 27 degrees Celsius. 4, you should have 268 degrees Celsius below 0, or negative 268. And then for number 5, every degree in temperature change in Celsius is the same as in Kelvin, so you should have 12 Kelvin for that. And then for practice, okay, try to do the rest on your own, okay, so, and then come back to the video and check your answers. So for 0 degrees Celsius, it's equal to 273 Kelvin. If we have Kelvin, then we subtract 273 to give us a minus 253. Here we have degrees Celsius, so you simply add 273. Okay, here you're going to minus 273, and so on. So it's back and forth. If you have Kelvin, you subtract 273. If you have Celsius, you add 273. So pause the video, do the rest on your own, and then come back and check your answers, please. All right, so we'll resume and going on. So you should have a negative 273, 160 Kelvin, 199 Kelvin, negative 268 degrees Celsius, minus 174 degrees Celsius, 304 Kelvin, 73 Kelvin, minus 236 degrees Celsius, 47, 272.5 Kelvin, and 25 below 0 degrees Celsius. So it is possible to have a negative Celsius value, but never a negative Kelvin value. This is the main reason that chemists use the Kelvin scale, because we don't have to worry about negatives. Okay? So as your exit, on pages 5 through 7 in your notes, they contain questions to ponder. If you complete these questions, you will receive your incentive for the 3rd marking period. So you'll have to check out the link for information about absolute zero to help you answer some of those questions. But I prefer that you not help each other with this if you want to get those extra 2 points on your average. Okay, guys, so happy pondering.